Last session we explained electromagnetic waves, and now I am going to continue the lesson of chapter 13, which is about electromagnetic waves and diffraction of light. So chapter 13. As I said, we explained electromagnetic waves, and now I am going to continue the chapter diffraction of light here. Second part of the lesson, diffraction of light. Okay, let's see diffraction of light. First, as a revision, you should know the types of beams, and this is a revision. You took this in grade 9 and the grade 10, and as you know, you have three types of beams: parallel beam or cylindrical beam. The rays are parallel to each other, like laser light, okay? The beam of laser light are parallel. Here you have divergent beam, which consists of rays emerges from one point. Most of the sources of light give divergent beam, like the lamp, the candle, etc. And you have here convergent beam. To get a convergent beam, you should put a convergent lens. Okay. As you see in these beams, the beam is considered to be infinite set of rays. Okay? And this is one ray. This is a ray. What is ray? A ray is the direction of propagation of light, is considered as a ray, and we can take very thin beam of laser light to represent a ray in reality. Okay, a very thin beam of laser light can be considered as a ray. Okay, so the second picture, let's see it. It is about the rectilinear propagation of light. فإذن كمان this is as a revision the principle of rectilinear propagation of light Okay, it says that light propagates in a straight line. Light propagates in straight lines. As a proof about the principle of rectilinear propagation of light, there is here a simple experiment. As you see here, you have 3 cardboards with the 3 holes and a candle and a boy that wants to see the candle flame through the holes. In order for the boy to observe the candle flame, what is the condition? The condition is that the candle flame and the 3 holes and the eye of the boy should lie along a straight line. If one of these 5 objects is shifted, then the boy will not be able to see the candle flame. This means that light propagates along a straight line. And this direction of propagation of light called a ray. Okay. Another proof about the principle of rectilinear propagation of light is the formation of shadow. As you see here, you have a sphere and you have a point source of light. The torch emits a beam of light, which is the divergent beam of light, as you see. So when it strikes with the object, light cannot penetrate the object, and so it continues to form the shadow here. Now, on what base is the shadow formed? If you notice, if you look at the edges of the beam, you notice that light propagates in a straight line. And also here, light propagates in a straight line. Okay? So that the shadow has taken this shape. This is schematic drawing for this one. This is the source of light. And here, this is the sphere. And here, this is the shadow. Here, this is a 3D. And here, this is 2D picture. Okay? And as you notice here, light propagates in a straight line. Light propagates in a straight line. So the screen from here on will be lighted, and from here on is lighted. And within this region, the shadow is formed because the object blocked the beam of light. Let's see a third example. Now, look at this, these pictures. And the title, Propagation of Light Through Large Openings. I mean by large opening, a large hole greater than, of diameter greater than 1 millimeter, okay? If you send a laser beam of light here through the hole, this is a cardboard, which is an opaque object that prevents the passage of light, and they made here a circular hole. And this is the screen. What do you observe on the screen? You observe a spot of light or a disk of light of same diameter as the hole here. Why? Also because light propagates in a straight line. So within the hole here, all the rays are parallel to each other, especially at the edges. Look at the edges. As I have drawn rays in a straight line, so I get here the image of the hole, which is a disk here, because light have passed through it. Okay? And also this is a 3D figure, and here this is a representation of this in a plane. As you see, this is the laser beam of light coming from laser source parallel to each other. This is a cylindrical beam of light. And as you see, from here on and from here on, light is blocked, whereas it continues parallel to, the rays continue moving parallel to themselves in straight lines, especially at the edges. Look here, at the edges, it continues in a straight line. So the spot here has the same shape as the slit or at the hole here. Okay, so also here, example, let's see, this one also an example, but this is a 3D. You have here a cardboard with rectangular opening, slit, but large slit here. It has large diameter, large length. And here the source is a point source here. Because of this, this beam is divergent beam. So, if we look at the edges of the rectangular hole, also light propagates in a straight line. Okay, light propagates in a straight line. And so the image here is formed, which is similar to the shape of the hole, but larger here. As you see here, it is larger, whereas in the previous, it had the same size. Why? The reason here that the laser beam is cylindrical beam and the rays are parallel to each other. So we get the same a spot of same size at the hole. But here the beam is divergent. So it will expand like a flashlight, okay? And so you get a size greater. But this doesn't violate that light propagates in a straight line. Okay. Also here, propagation of light when strikes thick edges. Yani, for example, this edge is large compared to light. Light has maximum lambda is 0.8 micrometer, which is negligible compared to this edge. This can be considered thick edge. Here, if I put a thick edge here and I send a laser beam, what do you notice or what do you see? From here on, because light propagate in a straight line, especially at the edge, okay, you get as a spot of light, of the laser light. From here and on, you will see dark region because the rays are blocked by the obstacle here. So on the screen you will see two regions. One region which is bright and a lower region which is dark. And there is an edge, clear edge between them. There is a clear edge separate the two regions. Okay? All these were examples about the principle of rectilinear propagation of light. The question now is the principle of rectilinear propagation of light, it is always valid? This is my question that we want to answer. Let's see. فإذن, is the principle of rectilinear propagation of light, propagation of light is always valid, or sometimes it is violated? Let us look at these figures. Now, as you see in the previous one, I am going to take this one, this example. As you see here, we said a spot of light or a disk of light of same diameter of the hole is formed. Right. What if this is similar one to that, but you have here a small opening? Look, this is a small opening. What do you mean by a small opening? Less than 1 millimeter. Okay? If I send the same laser beam to this opening, small circular hole, what do you observe on the screen? If you look carefully, maybe here the figure is not clear, you will see that what is formed here is a bright circular spot or disk surrounded by dark and bright rings. Dark and bright rings here. And I will show you the real figure. So in this situation, so the behavior of light has changed. When it passes through small hole, circular hole, it changes. First, I have seen that the image is only a disk of same diameter. But here you will see that the rings have diameter more than the diameter of the hole. Let us justify the observation. This is the screen. This is the screen with the hole. With the circular hole. And here this is the screen of observation, as you see. And here this is the laser beam. As we said, we observe a disk, a central bright disk surrounded by alternating dark and bright rings that have the same center as the disk. This is bright. The white ring here represents the dark ring. Now, if the principle of rectilinear propagation of light is applied, you expect to get what? A spot. A spot or a disk of same diameter as the hole, okay? As we have done previously in this figure. But as you see, we didn't obtain this. We obtain this shape. Right. Let's see. If you look here, this is a bright light. This means that light has reached this point, which means that light comes from the small hole to this point. Also, if you look at this point, there is light. Also, this means that light has left the hole and reached this point, which means that during its rectilinear propagation of light, the light deviates from its original straight line path and reaches this point. So you obtain an illuminated region around the spot that you have expected to get. And this is due to the deviation of the light from its original rectilinear path, which means that while the passage of the light through the small hole, it deviates and bends at the edges of the hole. This deviation or bending of light, when it passes through this circular hole, it is what's called the diffraction of light. Okay, let's look at the second observation at this figure. Also here, what do you have? You have a slit. This is a slit, a horizontal slit. And this is a laser beam of light directed toward the horizontal slit. What do you observe on the screen? You observe a region, illuminated region. You have here a central bright fringe, and then dark spots, and then bright fringes of less intensity than the central one. Also here, if we want to apply the principle of rectilinear propagation of light, light propagates in straight lines, you are going to obtain a spot of same width as the slit here. If this is A, you should obtain a spot of width A also. But you get here a region which is more of width more than A. Also here, if I take the last bright point here, this means that rays comes from the slit toward this point, also comes from this slit toward this point. So what happens here? Light, during its passages through the slit, it doesn't obey the principle of rectilinear propagation of light anymore here, at this position, at the edges of the slit. It has bended during its passage. It has bended and deviated from its original path. Also, this is called the diffraction of light, or the bending of light. And this phenomena, when you observe such phenomena, you know that there is a diffraction of light. And the principle of rectilinear propagation of light is violated. Okay, more observations. Look here. Here you have a laser light pointed towards a thin hair. And here this is a screen. What do you observe? Also you observe an illuminated region. Also consists of alternating bright and dark fringes, bright, dark, bright. dark, bright. How does this come? If also here you expect to obtain a shadow on the screen of same width you expect to obtain a shadow on the screen like this of same width at the hole, at the hair, and of length equal to the length of the laser beam. This is what you should expect, or what you expect. And this is due to the formation of the shadow as explained previously. But here you didn't get this spot, which means that also here the principle of rectilinear propagation of light is violated. Okay? Behind the hair there is a spot of light, and around the hair there are spots of light. Yani this means that light has deviated at the edges of the hair, and the part of it deviated behind the hair, and the part of it deviated away from the hair. And because of this, you have obtained a region of length more than the width of the hair. Okay? The propagation of light when strikes by a thin obstacle. You can do this experiment at your home. You can take a hair and send a laser beam towards it, and you can observe such phenomena. More observations. Look here, propagation of light when strikes thin edges. Also previously I explained the propagation of light when strikes thick edges. And there, this is what do we obtain. We said that we obtain a bright region and a well-defined dark region. These are well-defined, separated by a straight line. But will do we observe this with thin edges? Let's see. As you know, a razor blade is very thin, or has very thin border. Yani the edges of the razor blade when illuminated by light, see what do you observe? You observe a region of bright light surrounding it and around the edges. This bright light, this light comes from the source of light, and the light coming strikes the blade, and I am looking behind the blade. Okay? So you didn't obtain a well-defined shape of the razor blade. Why is this? Let's look at this figure. This is the same one, but in a vertical position. They take a part of this light around here and magnifies it. This is an enlarged view. They notice that there are alternating dark and bright fringes around it. And since this is the behind of the blade, this is behind rear view of the blade, okay? You notice here that there is light. Light has entered behind the blade, and you notice light here. So also, what happens is that light deviated when it strikes these thin edges here. It is deviated and form this view. Okay, this one is similar to this, and this is an explanation about what you're seeing here. Let's see more examples of diffraction. What is this photo? What is this photo? This is the photo, this is the shadow of a penny illuminated by a beam of light. As you see here, you don't obtain a well-defined black disc similar to that of the penny. But you obtain this shadow, a dark disc centered with a bright spot surrounded by alternating dark and bright fringes. Type. This is a shadow, yani this is behind the penny. This is the penny, this is the beam of light coming towards it, and this is its shadow. If there is a spot of light here behind that penny, this means that light has reached this point. Let's explain what's happening here, okay? This is the penny. This is the penny. And this is the laser beam of light, okay? Time. In order to obtain this view, what happened here is light is deviated at the edges. It is deviated like here at the edges and reaches the position at the center. In addition to this, it is deviated away, yani part of the beam reaching the edges, part of it is deviated away from the penny, and the part of it is deviated behind the penny. And you have infinite of beams here, or infinite of deviated rays that form the shadow and the rings. This is the shadow. With the central spot and the fringes surrounding the penny, the shadow of the penny. Also, there is this phenomena of the deviation of light from its straight path is called diffraction. Look at the CD here. All of us, when we look at the CD, you observe these colors. How do these colors come from? Also, let's explain this phenomenon. You know that the disc is made up of spiral track, grooved track. Yani, this is the CD, and this is the track, spiral grooved track. Okay? Like this. And so on till you reach the center. The distance of the groove, or the width of the groove, I'm going to call it A. It is about 1 micrometer, which is very small. When light strike a groove, it is reflected here. It is reflected. It is reflected in all directions. So, one direction like this, the second direction like this. At each point of the groove, you have many reflected rays. These rays comes from a width of around 1 micrometer, which means that as if the light is leaving a slit of width 1 micrometer, which is very small. So these all infinite radiations reflected by the CD, by the grooves of the CD, superpose with each other to give me these colors. Also, this is an observation about diffraction of light. Okay? From these observations, who can give me a definition about diffraction of light? Let's write a definition. إذن هوني diffraction of light it is the bending of light or the deviation of light from its original straight line path when it passes through thin slits, small holes, thin edges. Okay, this is the diffraction of light. If you take your 2 fingers and you make a small slit between them and you look at the lamp, you will observe alternating dark and bright lines that are also called the fringes. Okay? Fine. Now, this is a summary about the observed phenomenon or phenomena that I have explained. Okay. First here, this is the object. You have a sharp edge razor blade. This is the sharp edge, and here this is a laser beam directed. The laser beam is like this. This is a front view. A laser beam is striking the edge of the razor blade. What do you observe here? You observe like this, alternating bright and dark spots here at this point, and also behind the razor. This is a slit. This is vertical slit, as you see. This is called vertical slit. And you observe here a horizontal pattern of light, okay? And this is the case of thin wire or a hair also, and this is a spot of laser light striking it. Also you observe this pattern. And here you have circular hole, also you observe this pattern. All of these observations are different than what you expect if light propagates in a straight line. Okay?